All right, so we're going to talk about 7.5, multiplying and dividing radical expressions. So it's very similar to multiplying polynomial expressions where you distribute. The only thing that happens is that sometimes you can simplify more than you would otherwise because you might have a square root times a square root and you can simplify that product. So let's get started with a couple little reminders about radicals and how we might simplify them. So the square root of a times the square root of b is the square root of a times b. This works when it's multiplication. It would not work if that was a sum or a difference, if there was a plus or minus there, only if it's multiplication. Similarly, you can take the square root of a and square root of b if you're trying to separate it to maybe simplify a root. Another important thing particular to this lesson on multiplying and dividing is that we're going to end up having things where it's like root a, square root of a times the square root of a. So that is the same thing as the square root of a being squared. And what happens is the square root and the square cancel out, as we've seen before. And we know that a is always positive, so that rule about making sure that your radicand is positive when you're having the square root and a square cancel is going to hold true on these. The other way of doing it, of course, would be to take those two things that are the same, multiply them together, and then take the square root, and you'll recognize it gives you a as it is. So let's go ahead and just do a couple of these to get back in the swing of multiplying polynomials with, in this case, radicals. So 3 times 2 root 5 is the same as 3 times 2 times root 5, so it's 6 root 5. That's the F of FOIL. O, the outside times the outside. 3 times 1 is 3. I, the inside times the inside, root 5 times 2 root 5. Again, that's kind of like that, so we end up with either thinking of this as 2 times root 5 squared, or you can think of it as the square root of 25. There's 25 and then square root. Or you can take the square root of 5 and square it, and square root and square will cancel. So no matter how you approach it, you're going to get 2 times 5, so 10. And so your O and your I can combine. And then L, last times last, is root 5 times 1, so that's root 5. And so your F and your L can combine. In the past, normally it was your O and your I with your trinomials that could combine because they were like terms. This time more can. So we have 6 root 5 and 1 root 5. That makes 7 root 5s. Plus the 10 and the 3 make 13. You might have just a monomial. So this is the same thing as 4 times root 3 times 2 times root 5. Parentheses are just saying you're multiplying these two radical expressions, but there's like a 1 out in front that's being distributed. So it's 4 times 2 is the non-root part. It can be combined, multiplied, and then root 3 times root 5 is the same as root 3 times 5. So we end up with root 15. And the square root of 15 can't simplify because there's no square factors. So that would be done. The next one would be distributive property. So we have 3 times these two, so it's going to be 3 times root 14 when I do 2 times the 7 because they're both under a root, minus 5 square root of root 2 and the root 10. They're both under root. They're being multiplied, so that's root 20. So root 20 can actually be simplified, unlike root 15, because 20 is a perfect square 4 times 5. So it would be 2 from the square root of 4 times the square root of 5. So this ends up being 3 root 14 minus 5 times 2. So that's 10 root 5. These cannot be combined because they do not have the same radicand. So they are not like roots, not like radicals. Okay, this one, 3 times this would be 6 root 3. Then we're going to have minus 3 root 5. Then we're going to have plus 2 root 15, both under root, so you multiply them together because they are being multiplied right now. And then root 5 times negative root 5. So that's going to be a positive times a negative is negative. Root 5 being squared, they will cancel. Or you can think of it as root 25. And the square root of 25 is 5 also. So this one ends up being 6 root 3 minus 3 root 5 plus 2 root 15 minus 5. And there's no like terms, so it's those 4 terms. So this one had some terms that could be combined, this one not. Just a quick reminder on squaring, it means that you multiply by itself. It's important that you literally do that and that you don't bring the square to each term, okay? You can bring a square if it was factors, but not if it's plus or minus. So when I FOIL this, f, when I multiply this by itself, I'm squaring a square root. So this just becomes x minus 3. The outside times the outside, negative 5 times x, negative 5 times the square root of x minus 3. And we have another negative 5 times the square root of x minus 3. And we have negative 5 times negative 5. So let's simplify this. They have the same radicand, same index, so these are like roots. So we can combine our coefficients. We have negative 5 of them plus another negative 5 of them. So we have negative 10 of them. And then we have the negative 3 and the 25. So ultimately we can say x minus 10 of the x minus 3 roots plus 25 minus 3 is 22. Lastly, this is a pattern that you hopefully are kind of starting to recognize. We've got the same items, but one with a plus, one with a minus, and so they're called conjugates. That's going to be an important word that we're going to be seeing a lot of, especially when we deal with division. With roots and with imaginary numbers, so conjugate is where the middle sign are opposites. And what happens when you multiply conjugates is we get root 49, so that's 7, or you can say the square root being squared cancels, minus 3 root 7 plus 3 root 7. So the O and I of FOIL cancel because we have one with a plus, one with a minus. The rest are the same, so you're going to have opposite signs, and then minus 9. So you get that difference of squares. A plus B, A minus B, difference of squares. The square of the square root of 7 is 7, and the square of the 3 is 9. 7 minus 9 is negative 2. And so what happens when you multiply conjugates with roots or also with imaginary numbers later on is that you're going to end up with a nice rational number. So that'll be important later as well. So let's talk about division a little bit. Okay, to simplify an expression, we don't want to have any square roots in our denominator. So the way we can get rid of this, there's 2 ways, but one way we can get rid of it is think about, well, I want to square that to get rid of the square root. So I'm going to multiply it by itself. But if I do that to the denominator, I must do that to the numerator so that I don't actually change the value. I'm really multiplying this by 1. So I'm not changing the value, but I'm rewriting it. And now I can rewrite it as square root of 10 over root 2 times root 2. And you're squaring a square root, so it cancels. Or you can think of it as square root of 4, which is 2. So you get that nice integer. You got rid of the square root. This is called rationalized, and that's important process for making sure you are writing your expressions in simplified form where there's no roots in a denominator. If root 10 could have simplified, you would have gone ahead and continued to simplify the root and then divide if possible. So I want to get rid of that root 5. So if I square it, if I multiply it by another root 5, what you do on the top, you do on the bottom, or what you do on the bottom, you do on the top, you end up with 2 root 15 over 3 times 5. So that's going to be 15. These 15s don't cancel. That's underneath the root. That's not. And the 2 and 15 can't simplify, so that's as far as you can go. The 15 doesn't simplify, as I mentioned a few minutes ago, so I couldn't simplify that root. But if it was like root 20, I could, and I maybe could go further in simplifying the expression. All right, so I've been mentioning this rationalizing the denominator, making sure there's no root in the denominator. But how do you do that when there's, you can't just square something that's square rooted and get it to go away? So the way you do that is with that conjugate that I mentioned. It's where that middle term sign changes, basically creating a difference of squares. So if you had a plus b, then the conjugate would be a minus b. Or if you had a minus b, the conjugate would be a plus b. And it's about the denominator. You want to make sure there's no root in the denominator. So you are going to multiply by, in this case, 4 minus root 3, the conjugate of the denominator. You're making a giant 1, so you don't change the value of the expression. So now I just multiply the numerator. I've got 3 times both these. So I end up with 12 minus 3 root 3. And then I have 4 times 4 is 16. 4 times this would be negative 4 root 3. Then I have plus 4 root 3. These canceling is a really good sign because you're trying not to have any roots. And then root 3 times root 3, it's positive times negative, so negative. The roots will cancel because you're squaring. Or you can think of it as the square root of 9, which is 3. So let me just simplify this a little bit. It might be tempting to do 12 minus 3 and write 9, but you have to pay attention to order of operations. You'd have to do your multiplication before your subtraction, and that's these are not like terms, so you can't subtract them. So it's just that over 16 minus 3 is 13. If all of the coefficients would be divisible by, let's say, 2 or 3 or 5 or something like that, then you would simplify that fraction. So in other words, factoring and then seeing if there's a common factor. You can leave it like this. You can put it in factored form. It's up to you. Instead of factoring, as I mentioned, you can also see if all of them go into something. We'll see that in a minute. Yes, and I believe it will be happening in examples 10 and 11. So I'm going to project those and just discuss them rather than doing them all. So here's number 10. I did the conjugate of the denominator. So root 5 plus root 3 becomes root 5 minus root 3 as its conjugate. So I'm going to multiply by a giant 1, that's 1, made up of the denominator's conjugate. So then I FOIL, F-O-I-L and F-O-I-L, simplify, and then this has negative root 15 plus another negative root 15, so I have negative 2 root 15s, and the 5 and the 3 make 8. Because all of the coefficients are divisible by 2, I can divide each by 2. So I divide by 2, divided this by 2 gives us one of them, and divide gives you 1, which you don't need to put the 1, you can just simplify it as 4 minus root 15. For number 11, the conjugate would be root 7 plus 3, distributing, and foiling. O and I of FOIL end up canceling because of the whole point of doing the conjugate is to get rid of them, to have them be opposite so that they cancel out. And 7 minus 9. Again, it's root 7 times root 7. That's root 49. The square root of 49 is 7. Or the square root of 7 is being squared. It's being multiplied by itself. And so you get square root and square root cancel to leave you with 7. In this case, you're going to divide each of these by negative 2. You could also have done it by factoring. and then that would go into -1 time. And then you could divide each of those by -1 because now it's a monomial. Or you could have divided each of these by -2 as I did here. All right, and then lastly, this one is rationalized. There's no square root in the denominator. However, it's just a reminder on how to simplify. You look at all the coefficients and what they can all go into, and that's what you're dividing each of them by. So the 8 divided by 4, 4 divided by 4, and 16 divided by 4 would allow you to simplify that. You can rewrite it as 2 divided by 4, 1/2, and root 10 divided by 4. You can factor out of 4 originally and do it through factoring, but no matter how you approach it, your final answer is going to be equivalent to this. Please don't forget that both of these are being divided by 4, just like both of these were being divided by 16. Even if this had been like, I don't know, an 8 divided by 4, don't say 2 minus root 10, it would be 2 minus root 10 over 4. All right, so that is it for this section.